अभी भी electrophilic substitution ठीक है, we're still doing electrophilic substitution ठीक है. So just a quick recap. I told you benzene has two electrophilic substitution reactions. Actually, there are more than two. Abhi filhal we're just focusing on these two. One is with halogens. So we did this bromine aata hai and bromine gets attached to it. Chlorine comes in, chlorine gets attached to it, but you need a catalyst for that. Or you also have a nitration reaction in which NO2 comes in and joins with the benzene. Okay? These are the conditions: concentrated nitric acid. The mechanism of the reaction is so the mechanism of the reaction is the benzene electron density is not very high, so the bromine molecule does not get polarized, which is why you need a catalyst. वो इधर electrons repel कर रहा है, on the other side the iron is attracting electrons. That's how bromine gets your positive charge, and this bromine gets a negative charge, okay? And the bond breaks eventually. The positive bromine gets attracted to this electron, bonds with it, okay? That is gone, and when that happens, तो फिर next part है कि the H then loses electrons and gives it back, and the electron cloud becomes complete again. So this is substitution. Okay? One comes in and the other one leaves. So this was the reaction, and the same reaction happened with nitration as well. Okay? NO2 plus 1 came in, took away electrons, and then the H is the one that leaves, gives the electron back, and the electron cloud becomes complete again. Okay? That's what's happening. Okay? So you should know the mechanism. That's very important. Or the other thing was, this was the mechanism. So we had started talking about electron donating groups, and I told you if you have a benzene and on one side instead you have a carbon chain, the carbon chain has an electron donating effect. So what it will do is that it's going to increase the electron density on one side of the benzene, and all the other electrons are going to get repelled, and the electron cloud will concentrate on the opposite side. So the electron density will become higher at positions number 2, 4, and 6. So अब ये होगा कि if there is an electrophile like NO2 plus 1 or Br plus 1 that's coming in, those electrophiles will be more interested in positions number 2 and 6 and 4. They'll be more attracted to it. So the substitution will actually the more likely chance is that the substitution will probably happen at positions 2, 4, and 6. This was electron donating effect. Okay? This is what we discussed last time. And I told you that there were a number of groups which are 2, 4, 6 directing. ठीक है, जिसको 2, 4 groups कहते हैं. So your alkyl chains, that's one. We did this one at the moment. ठीक है. You've got chlorine, amides, OH groups, NH2s. These are all electron donating groups. ठीक है. So your reaction is exactly the same, except for the fact that now the bromine has to decide which position it's going to get attached to. The catalyst is the same, the conditions are exactly the same, except for the fact that either the bromine or Cl will get attached to positions number 2, or they'll get attached to position number 4. और यहाँ पे भी ये होगा NO2 के केस में, it's either going to be attached to position number 2 or it's going to be attached to position number 4. ठीक है, so 2, 4, 6. ये हमने last time किया था. So is this clear? ये सारा clear है?
सर
हाँ जी.
सर वैसे जब लाइक 3 आ जाए ना तो इसके अंदर तो फिर 2, 4, 6 इस तरह से मेंशन कर सकते हैं ना. वैसे नॉर्मली 2 और 4 कहते हैं.
हाँ, वो 3 में 6 आ जाता है, लेकिन वरना नॉर्मली वो, क्योंकि 2 दूसरी साइड से भी ना, इट्स स्टिल गोइंग टू बी 2. तो वो जब अनलेस 2 पे भी हो और फिर 6 पे भी हो, देन यू गोना कॉल इट 2, 6. ठीक है. अच्छा, एनीवेज ये वाला हो गया, बट नाउ इट्स इलेक्ट्रोफिलिक सब्स्टिट्यूशन स्टिल नॉट कंप्लीट. ठीक है, वी स्टिल हैव टू स्टडी द इलेक्ट्रोफिलिक सब्स्टिट्यूशन ऑफ phenols and phenylamine. ठीक है, so the next part is that is electrophilic as a substitution of, so there's a thing called phenols and phenylamine. अच्छा एक सेकंड मेरा इंटरनेट आवाज आ रही है
यस सर।
यस सर।
अच्छा जी मेरे ख्याल से बोर्ड हैंग हो गया जस्ट अ सेकंड या फिर शायद हमारे बोर्ड पे ना बहुत सारी चीजें हो गई हैं तो आई वुड हैव टू चेंज द बोर्ड जस्ट अ सेकंड ये मैं कह रहा था एक ही बोर्ड पे खत्म हो जाए अच्छा वो रीस्टार्ट है चलो उस साइड पे चल इधर मैं कर रहा हूँ अच्छा इलेक्ट्रोफिलिक सब्स्टिट्यूशन ऑफ फिनॉल्स एंड फिनाइलमाइन 1 second हाँ ठीक है आ गया अच्छा फिनॉल्स एंड फिनाइलमाइन अच्छा अगेन दिस इज आल्सो 246 डायरेक्टिंग ग्रुप्स ठीक है ये OH and NH2 these are also 2 4 and 6 directing groups अच्छा अब ये कि phenol is this thing phenol is it's a benzene which has so you've got a benzene और उस benzene का ना it's got an OH group that's attached to it ठीक है so I've got ठीक है बीच में there's this ring and there's going to be an OH group now this thing is basically your phenol अच्छा plus phenylamine is exactly the same thing except के the phenylamine will have an NH2 instead
सर बेंजीन विद OH इज फिनॉल।
हाँ benzene with OH that's phenol ठीक है और ये दूसरा जो है ना it's got NH2 attached to it but this is not a phenol this is going to be phenylamine अच्छा this one is going to be phenylamine अच्छा अब ये कि and remember this when I say phenol it's not an alcohol ठीक है ये याद रखना कि this is a different functional group ठीक है and OH with benzene that's it's not an alcohol और similarly वो दूसरा वाला ना that's not a normal amine that's a phenylamine ठीक है which is different अच्छा both of these अच्छा now the question is both of these compounds they've got a benzene और उस benzene के अंदर issue ये होगा कि for both of them uh, that this is 246 directing what happens is कि ये जो ऑक्सीजन है ना इन this oxygen over here, it has a lot of lone pairs. ठीक है, oxygen has four electrons, which basically means two lone pairs. N also has lone pairs. There's a lot of spare negative charge. What happens is कि इसके अंदर भी ना फिनॉल के अंदर भी the electrons they start overlapping with benzene's electron cloud. So what eventually happens is, इसकी मैं कॉपी वैसे रेफरेंस के लिए बना लूं. अच्छा, now what happens is कि these lone pairs they overlap with benzene's electron cloud, and eventually यहाँ पे ना the electron density is significantly higher because benzene का तो अपना electron cloud था, plus these lone pairs they all start overlapping with each other. Or as a result, what happens to all the other electrons? All the other electrons they get repelled and they become concentrated on the other extreme side. ठीक है, is this clear? तो कौन सी पोजीशंस पे
सर
हाँ,
सर सर रिपीट कर सकते हैं सर?
वो जैसा अल्काइल चेन नहीं था, this OH also has an electron donating effect. कि electron donating effect in a way कि it's got, ठीक है, it's got electron donating effect क्योंकि उसके पास फालतू के इलेक्ट्रॉन्स है ना, वो has lone pairs, right? This one clear है?
यस सर.
वो lone
हाँ
pairs
यस सर.
they mix up with the benzene electron cloud. तो यहाँ पे इस साइड पे there's a lot of negative charge because these lone pairs and the benzene electron cloud they all start overlapping with each other. Is that clear?
सर तो लाइक अगर दो लॉन पेज है तो दोनों लाइक दोनों एक्सट्रीम पोजीशंस पे जाएंगे ना, एक राइट पे और एक लेफ्ट पे.
क्या मतलब राइट पे और लेफ्ट पे?
सर जो आपने मतलब ड्रॉ किया यहाँ पे, मतलब राइट साइड वो बेंजीन का कॉन्सेंट्रेट नजर आ रहा है इलेक्ट्रॉन पेयर के साथ, वो मिक्स मिक्स कर रहा है उसके साथ.
हाँ, क्योंकि वो इलेक्ट्रॉन्स ओवरलैप कर जाएंगे ना. कि मतलब
ओके
बेंजीन
सर.
बेंजीन की शक्ल किस तरह थी? बेंजीन वाज लाइक दिस, कि मतलब जो एक्चुअल बेंजीन था. सेम चीज हो रही है ना यहाँ पे. अब OH है इंस्टेड. इवन इफ आई, यहाँ पे OH है तो O के हैज लोन पेयर्स, तो वो लोन पेयर्स के साथ ओवरलैप होंगे इन इलेक्ट्रॉन्स के साथ. सो द नेगेटिव चार्ज ओवर हियर ऑन दिस साइड विल इंक्रीज. इज दैट क्लियर?
यस सर.
तो सेम सिनेरियो है, वही पहला वाला. ठीक है, except for the fact के now the negative charge is significantly higher. ठीक है, ये 2 4 और अच्छा, the negative charge is going to be significantly higher. पिछला जो सिनेरियो था ना, that was a normal alkyl chain. Alkyl chain does not have lone pairs. उसका बस हल्का सा tendency होती है to push electrons. So the effect is very slight electron donating effect. Now the question is, same situation, but there's a very large electron donating effect. Is that clear?
यस सर.
क्योंकि अब तो उसके पास it's got spare electrons. ठीक है, so this one is going to be a very large electron donating effect. And the same thing happens with NH2 as well. ठीक है, it's again 246 directing. तो उसके जो lone pairs है ना, they would overlap and the electron density is going to become significantly higher on one side and all the other electrons in the benzene are going to be pushed to the other side. तो वो फिर
सर
positions 2 4 and 6. हाँ जी.
और सर वो अल्काइल के अंदर तो स्लाइट इलेक्ट्रॉन डोनेटिंग इफेक्ट है ना.
हाँ, यहाँ पे large है.
हाँ.
ठीक है, क्योंकि यहाँ पे लोन पेयर्स है ना, उनके पास they've got लोन पेयर्स और वो लोन पेयर्स they start overlapping with. तो ये NH2 का भी ना there's going to be a large अच्छा, there's going to be a large electron donating effect. ठीक है, तो और ये लिख भी देते हैं नीचे क्या हो रहा है कि so what happens is कि lone pairs overlap. तो lone pairs on oxygen in hydroxy group या फिर और N in NH2. अच्छा, they overlap with electron cloud and significantly increase its electron density. Increase the pi electron cloud, the electron cloud density. Pi electron cloud लिख देते हैं complete. अच्छा, बस ये बता दो कि what will happen to the reactions? Will the reactions be faster or more vigorous or slow? Electrophilic. If there's an electrophile, so it will be attracted to positions 2, 4, and 6. So क्या होगा? Is the attraction going to be stronger?
So vigorous.
ठीक है, now it's going to be a vigorous reaction. So previously it wasn't a vigorous reaction, ठीक है? Now it's going to be a very vigorous reaction. So what happens is that the electrophile, और आपके पास you had two electrophiles. You had NO2 plus 1 और Br plus 1, ठीक है, वो Br2 में से. These electrophiles will be strongly attracted to benzene. So faster reactions and milder conditions. I mean, you don't need extreme conditions. अच्छा, तो इस केस में ना the conditions will change. So if I copy the same reactions, okay, everything will be 2, 4, 6. इधर बस I'll just copy all of these reactions, previous one. So they would be exactly the same 2, 4, 6 reactions, ठीक है? अच्छा, बारी बारी में इसको ठीक करते रहते हैं. So phenol with Br2, first one. अच्छा, so I've got a phenol, ठीक है, reacting with the Br2. So the Br is obviously going to get attracted to position number 2, but the reaction is so vigorous you only get one compound. You don't even get the other compound. Okay? You get one compound, which is only one compound is obtained. That the Br will get attached to positions number 2. It's also going to be attached to position number 4 and 6 in one go. ये नहीं होगा कि वो step wise. It's not going to happen step wise. ठीक है? The reaction will happen in, ठीक है, one Br getting attached to position number 4 and another Br getting attached to position number 6. ठीक है, तो सारे एक ही go में ना simultaneously they get attached. And this is known as tribromophenol, ठीक है, और 2,4,6 tribromophenol. अच्छा, and this tribromophenol, that's a white precipitate that is formed. ठीक है, so you get
Sir,
हाँ जी.
सर ये थर्ड ब्रोमीन वो कैटलिस्ट से आया था.
नहीं, वो उतनी, एक सेकेंड, यहाँ पे मुझे वो ऐड करने दो कि HBr भी होगा. ठीक है, there's going to be, every time a bromine gets attached, there's an HBr molecule that's produced. So there's going to be 3 HBr molecules that are produced. Balance कर लो ना. Okay, it's going to be reacting with 3 Br2s. Is that clear? Achha, so first thing, okay, electron density is so high in phenols that the bromine, it's not one bromine getting attached. It's actually the bromines get attached on all 3 positions because the attraction is very, very strong. ये बात clear है?
Yes, sir.
ठीक है, सारों को clear है?
Yes, sir.
Achha, so the attraction is very strong. So, achha, plus अब ये 3 molecules क्योंकि वो CBr go over here. वो हर जगह ना there's an H getting substituted, so that H goes and bonds with the other 3 Brs. ठीक है? So इसलिए you need 3 Br2 molecules. Achha, plus another thing is conditions. Conditions are you don't need a catalyst now. ठीक है? And it happens at room temperature. The reaction is very fast. ठीक है? It's you don't need any catalyst. The conditions are room temperature. हाँ, ये हर दफा HPR प्रोडक्ट था ना, मतलब if you go back तो वो जो पिछले mechanisms थे मतलब in the Cl2 this one, तो वो जो H when that H gave the electron back, so one of the Br was bonded to one of the Br becomes positive, the other one becomes negative, right? So the positive one joins with the benzene, वो जो negative one है ना वो बाद में फिर it takes away the H and forms HBr. अच्छा, अब ये कहाँ पे थे? अच्छा, इस पे फर्स्ट वाले पे थे, ठीक है? So this one, it's going to be 2,4,6 tribromo or phenol है. Plus, I told you the conditions are RTP. You don't need a catalyst. No catalyst required. So why is no catalyst needed? Because the benzene electron density is so high that it can polarize the bromine molecule all on its own. It doesn't need any help. So इसलिए no catalyst is needed. Plus, इसमें ना one more thing, Br2 aqueous is used. Make sure you remember this. Okay, only Br2 aqueous is needed. Okay, remember ये aqueous. Make sure you write aqueous. That carries a mark most of the time. It's Br2 aqueous, not just Br2.
Sir.
हाँ,
सर पिछले वाले में Br2 aqueous था ना?
नहीं, पहले से Br2 था, liquid. और Br2 plus catalyst था. But over here it has to be an aqueous solution. Or the same thing with will happen. I'll just ये पुराना वाला था Cl2 के साथ. The new one would kind of be so the new one is going to be exactly the same except it's going to have Cl. तो यहाँ पे बस I'll just quickly change this to Cl2 and this is going to become Cl2 aqueous. ठीक है, गलत वाले को चेंज कर दिया, एक सेकंड. अच्छा, नीचे वाले को चेंज करना. हाँ, मतलब only Br2 means not aqueous basically. It's just Br2 liquid. अच्छा, this one it's Cl2. All of the 3 atoms getting attached, that's going to be Cl2 on 2, 4, 6 positions. and it's going to be a 2,4,6 trichlorophenol. It's going to be a 2,4,6 trichlorophenol. Or conditions change the condition, it's going to be Cl2 aqueous. So it's going to be Cl2 aqueous. Now, the thing is that I said it's going to be Cl2 aqueous. The next thing is that so now the next thing is iski importance, the reaction. There's one importance of this reaction, and that is that it's a test for identification of phenol, specifically this reaction. It's a test for identifying phenols. इसको उसमें बॉक्स बना देते हैं. So this one is a test for identification of phenols. Now two things happen. One is that the red, brown, or orange bromine gets decolorized. So red, orange, Br2 aqueous decolorizes, and you also get a white precipitate. Alkenes, it would only decolorize. But now the situation, it's going to decolorize and simultaneously and produces a white precipitate. Okay, so it's going to so ये बस important चीज है कि it's a test for identification. Let me underline this. So it's used as a test for identification of phenols. That's it. और इसके बाद ये कि इसको थोड़ा सा नीचे कर लें. अच्छा, तो ये सारा क्लियर है. मैं बस समराइज कर रहा हूँ. हाँ जी
सर, जो सब्स्टिट्यूशन है बेसिकली वही उसकी आइडेंटिफिकेशन लाइक है.
मतलब वो रिएक्शन उसकी आइडेंटिफिकेशन है ना. रिएक्शन में तो ऑब्जर्वेशन और आइडेंटिफिकेशन. So the summary is, with OH and NH2, the electron donating effect is very large, which is why the electron density is very, very high on the benzene at positions 2, 4, and 6, which is why the electrophile is very strongly attracted to it. So when you do a reaction of phenol with either bromine or chlorine aqueous, you don't need a catalyst. Okay? You don't need to polarize the molecule. It will get polarized on its own. Which electron density is so high that it will push the bromine electrons and polarize it all by itself. Okay? And once that happens, bromine not only gets attached to a single position, it actually gets attached to all three positions because the force of attraction is very, very strong. Electrophile and the benzene electron cloud are very strongly attracted to each other. So all three positions, they और ये confirm नहीं, मतलब ये कोई वो लाजमी नहीं है कि all three positions. Maybe it can be two positions, it can be one position, but the more likely scenario is that all three positions are going to get filled. अच्छा, ये भी confirm नहीं होता कि it's going to be 2,4,6. The more likely chance is that it's going to be 2,4,6. Like if you have 10 molecules, then 9 of them are going to be 2,4,6. One of them might not be 2,4,6. अच्छा, coming to हाँ जी
सर, वैसे एग्जाम के अंदर वो लाइक पूछ सकते हैं कि अल्टरनेटली लाइक 246 नहीं हो सकता तो और कौन सा हो सकता है?
नहीं, फिर तो और तो कुछ नहीं रहा, फिर तो 3-5 ही होगा ना.
ओके.
आपने जो एग्जाम में ड्रॉ करना है ना, वो मोस्ट लाइकली वाला ड्रॉ करना है. ठीक है. अच्छा, नाउ लेट्स टॉक अबाउट नाइट्रेशन. तो नाइट्रेशन के अंदर भी ना सेम सिनेरियो कि व्हेन यू डू नाइट्रेशन ऑफ अ फिनॉल, तो अगेन द इशू इज द इलेक्ट्रॉन डेंसिटी इज प्रीटी हाई. जब OH अटैच्ड होगा ना, the electron density is going to be very high at positions 2, 4, and 6. So now there's going to be two scenarios. The reaction, you don't need a catalyst. You don't need temperature 55 degrees centigrade. ठीक है? The reaction will happen in much milder conditions. You don't even need concentrated nitric acid. The reaction can happen with dilute nitric acid. वो जो भी polarization है, that will happen on its own. The phenol electron density is very high. अच्छा, वैसे तो 2,4,6 trichlorophenol का ना, the color is not in your course, but most likely it's going to be white precipitate. ट्राइब्रोमोफेनॉल ना, वो बेसिकली टेस्ट है, वो याद रखना है इसे, लेकिन I'll just search it कि ऐसे कोई एंटीसेप्टिक है, ठीक है. I guess it is a white precipitate. This is what it looks like. I don't know if it's white है या cream है. I guess it is a white precipitate as well. I'll show you 2,4,6 tribromophenol. That's a tribromophenol. That's इसका image नहीं है. So this is, both of them, they kind of look exactly the same. This is 2,4,6. I guess this is 2,4,6. हाँ, ये मेरे ख्याल से कोई बेच है. तो this is 2,4,6 tribromophenol. वो मेरे ख्याल से थोड़ा सा क्रीम है, but no one is going to ask you about chlorophenol. उसका जो color है ना, that's not in your course. उसका reaction is in your course. The test is with bromine. So tribromophenol, that's the one that you got to remember. अच्छा, इस पे आ जाओ phenols के ऊपर वापस. Nitration. Remember, I explained to you that you don't need very strong conditions. वो reaction dilute nitric acid से हो जाएगा. And you'll get an NO2 on position number. So you'll get an NO2 on position number 2 or position number 4. So one of them is going to be called phenol has a higher precedence. OH has a higher precedence. So it's going to be called 2-nitrophenol. And this one, the one that's number 2. And this one is going to be called, this is 1, 2, 3, and 4. So this one is 4-nitrophenol. So this one is 4-nitrophenol. So reaction dilute nitric acid. ये मैं पिछले देख लूं, did I change the names? हाँ, किए थे. हाँ, अब why not 2,4,6? Well, you're going to have 2,4,6, ठीक है? You're going to have 2,4,6, but for that, that will happen कि अगर आपके पास ना वो हो. So that will happen if you have concentrated nitric acid. So if you use concentrated nitric acid, again, no catalyst required. No temperature required, 55. So then what will happen is, because the benzene is so activated, it's so activated that the NO2 gets attached to all positions. And this becomes NO2, this also becomes NO2. So all of them become NO2, and now it's going to be called 2,4,6 trinitrophenol. नाइट्रोफिनॉल। तो थोड़ा सा रिएक्शन चेंज हो गया, थोड़ा सा। I mean, slightly the conditions have changed. Phenols, the mechanism is exactly the same. But why the conditions have become slightly milder. Previously, you had Br2 plus FeBr3 catalyst. Now you don't. No catalyst needed. Previously, only one Br would get attached. That was the more likely scenario. Now, Br will get attached to all three positions. Same situation with nitration as well. That's previously you needed concentrated sulfuric acid as a catalyst. Ab you don't need a catalyst. No catalyst needed.
सर
हाँ जी,
सर ये नाइट्रिक एसिड एज ए रिएजेंट यूज हो रहा है ना?
हाँ, एज अ रिएजेंट यूज हो रहा है, उसी से इलेक्ट्रोफाइल आ रहा है, ठीक है। तो ये और ये 2,4,6 ट्राई नाइट्रोफिनॉल, ये सारी वाइट प्रेसिपिटेट होते हैं। एक सेकेंड, बस एक सेकेंड। पिक्रिक, ये पिक्रिक एसिड इज दिस थिंग, आई थिंक। Yeah, that's not a white. It's a yellow, pale yellow crystalline solid. मैं एक दफा वो पिक्रिक एसिड का चेक कर लूं, इज इट द सेम थिंग? 3NO2 picric acid, हाँ ठीक है, picric acid, this is picric acid. So this is a yellow crystalline solid. वो लेकिन याद रखने की जरूरत नहीं है, कलर वो उसका ही मांगेंगे। 2,4,6 ट्राई नाइट्रोफिनॉल, सॉरी ट्राई नाइट्रो, नहीं 2,4,6 ट्राई ब्रोमोफिनॉल का, because that's used as a test. This is not a test, so they're not. Plus इसका कलर भी नहीं है उसमें, ये वैसी साइड पे लिखा हुआ है, येलो क्रिस्टलाइन। अच्छा, देन बस एक आखिरी चीज है कि यहाँ पे ना, I talked about two things. I talked about phenols and I talked about phenylamine. Repeat everything with phenylamine. Both of them will have exactly the same electrophilic substitution reaction. तो ये जो बाकी सारा है ना, you just change the, I mean, OH की जगह ना just change NH2 and it's going to be the same thing. तो ये मैं बस end में ना, I can probably just add either side पे ना, I'll just add के इन सारों के साथ कि this could be OH, it could also be, but it could be phenol or it could be NH2 as well. तो ये,
सर
हाँ
सर तो मतलब लाइक एरीन थोड़ा सा स्लाइटली डिफरेंट है और जो फिनॉल और फिनाइलामाइन है वो सेम है ना इन टर्म्स ऑफ मैकेनिज्म?
नहीं, इन टर्म्स ऑफ कंडीशंस, मैकेनिज्म तो सारों का सेम है ना। मैकेनिज्म
ओके
मैकेनिज्म तो सारों का एग्जैक्टली एक ही है ना, इलेक्ट्रोफिलिक सब्स्टिट्यूशन है। कंडीशंस की बात हो रही है, द कंडीशंस। अच्छा, तो यहाँ पे आई जस्ट कॉपी दिस एवरीवेयर, ठीक है। तो NH2 होता वुड हैव बीन द सेम थिंग। थोड़ा छोटा कर लेते हैं। और यहाँ पे भी ठीक है। तो जस्ट रिमेंबर बोथ ऑफ देम विल हैव एग्जैक्टली same things happening. So that basically partially covers, थोड़ा सा रहता है electrophilic substitution. So just remember that you had arenes, they had arenes and benzene had the same conditions. Phenols and phenylamine have slightly milder conditions and they have slightly faster reactions. Clear बात?
यस सर
तो चले, ठीक है, ये फिर कल कंटिन्यू करते हैं, ठीक है।
सर
हाँ जी,
सो वो एक सॉरी वो थोड़ा सा रेट के हवाले से पूछना था जो रिएक्शन काइनेटिक्स के अंदर है।
हाँ
सर
हाँ
उसके अंदर वो एक इक्वेशन है k इज इक्वल्स टू 0.693 डिवाइडेड बाय हाफ टी। सर उसके रिलेटेड मुझे क्वेश्चन नहीं मिला अभी तक।
हाँ, उसके रिलेटेड मुझे भी आज तक कभी कोई क्वेश्चन नहीं मिला। वो
सर तो लाइक कोई आपके पास
वो
सोर्स है
सिंपल
जैसे प्रैक्टिस
वो
कर।
सिंपल ये है कि हाफ लाइफ है ना, अगर अगर आपको
यस
हाफ लाइफ पता है ना, तो के जो है ना, दैट्स उसको हाफ लाइफ से डिवाइड कर दो।
ओके सर
0.693 डिवाइड बाय टी हाफ, ठीक है। लेकिन
ओके सर
उसके लिए ग्राफ होना चाहिए, हाफ लाइफ का पता होना चाहिए। अगर आपको हाफ लाइफ पता है ना, तो उसमें बस यही आ सकता है, ग्राफ से देख के ना वो कहेंगे कि हाफ वो बता दो, के की वैल्यू बता दो, तो बस हाफ लाइफ से जाके डिवाइड कर दो, बात खत्म।
ओके सर ओके सर।
ठीक है, चलो, ओके, अल्लाह हाफिज।